Okay, good morning. This is Professor David J. De Los Reyes. It's October 18, 2023. The time is 4:32 a.m. My topic for this session will be a long video format lecture on trigonometry, and we are now on lesson number 4. We are running smooth, okay? Okay, let's proceed. The subject matter for this morning will be trigonometry, lesson number 4. And the title of the topic is Example Problem on Linear Speed and Angular Measurement. So we are still on the so-called study of angles, but as an addition to the subject matter angular measurement, I will try to introduce linear speed. Linear speed. Okay, I will try to read the problem. A truck is traveling at the rate of 35 miles per hour, goes through a circular curve of radius 1,450 feet. Okay, that's a long one. 1,450 feet, that's almost 5,200. It's almost 1/3 of a mile. Okay, through what angle does it turn in 30 seconds? So, this problem here falls under the study of angular measurement, but as an addition, okay, we are given a linear speed of 35 miles per hour. So how could we relate that linear speed to angular measurement? Okay, let's try to bring out a figure. We got a circular curve, okay, assuming this is the center of rotation, and if we try to measure the length of the radius of the circular curve, okay, this is the center point. So if we try to make a, what do you call this, a circle, we'll rotate it like this, okay, so the path of that circle will be the path of the truck. And according to the given problem, the radius of the curve, the radius of the curve is 1,450 feet. That's almost 1/3 of a mile. Okay? The truck is traveling at the rate of 35 miles per hour. Okay? And the problem is asking at what angle does it turn in 30 seconds? If this line here is the initial line, okay, the next line will be the final line. The final line. Right? So from the initial line to the final line, which occurs in a time t equal to 30 seconds. 30 seconds. Meaning to say from this point here, up here, the time that elapses is 30 seconds. So the problem is just asking what will be the angle, okay, traveled by the truck, after 30 seconds. So what is being asked is actually this theta over here. Okay. Pi theta. The angle, okay, traveled by the truck, okay, after 30 seconds, if the radius of the curve is 1,450 feet. So the given in the problem is the linear speed of the truck is 35 mph. Mph is actually miles per hour. And the time involved is 30 seconds. And small letter r, we can use is big R, it's still a radius. Small letter r or big R, still a radius. So the radius is 1,450 feet. From this center point up here, this is 1,450 feet. Okay, so the problem is asking what will be angle theta after time t equal to 30 seconds and the speed is 35 miles per hour. Okay, let's try to bring out the solution. To bring out the solution, okay, I will let capital letter B equal to linear speed, and this will be constant. This is not variable, constant. So meaning to say the track is in constant motion, right? And the given linear speed is 35 mph, meaning miles per hour. Okay, let's try to bring out or compute for the total distance traveled by the track after time t equal to 30 seconds. The linear speed is, right? So for linear speed, linear speed, linear distance is actually velocity or speed multiplied by time. For this to be correct, this velocity here should be constant. Okay, it's not accelerating, because if it is accelerating, we add something over here, and that's a different story, right? So by using the equation for linear distance, that is distance s traveled by any moving thing in a straight line, is the constant velocity multiplied by time. So even though the track is traveling in the curved path, in the computation of its total distance traveled, okay, we'll use the straight line method, right? The straight line method will be velocity times time. Okay, let's try to put the values with the proper, what you call this, designation. Velocity is 35 miles per hour, meaning per hour is per 1 hour, right? Right? The time is 30 seconds. So this is times 30 seconds. So this part of the solution here is actually the conversion problem. Conversion part. Because the product of 35 times 30 seconds is just this velocity times time. But we must have to convert some values here for us to make some cancellations. So we'll try to eliminate these seconds here. So we must have to multiply this one by, we know that 1 hour is 3,600 seconds, right? So this is times 1 hour per 3,600 seconds. Okay? And we must have to eliminate these miles here for the distance to be in feet. So this is times 5,280 feet. 5,280 feet per 1 mile. Okay? You got it? Miles per hour times seconds times hour per second times feet per mile. These are correct relations, okay? If you try to put some conversion over here, it should be the correct relation. It's a fact that 1 hour is 3,600 seconds and 1 mile is actually 5,280 feet. So this is times 50 to 80 feet per mile. Then try to make some cancellations. The unit of the distance that will come out will be the remaining unit, okay? So these miles here cancel with this. First mile. Numerator, denominator, right? The operation here are all multiplication. So we are free to cancel. Okay? The operation are all multiplication. We are free to cancel. But if there is a plus sign over here, then you try to cancel mile and mile. That's a different story. Okay? We can cancel as long as the operation on both the numerator and denominator are actually multiplication. So these miles here, I'm just telling you the error, common error, okay, on the cancellation. Cancel with mile, and this hour here cancel with this hour, and this second here cancel with this second. Numerator, denominator, numerator, denominator. Okay, second is a numerator, denominator, so it cancels. Okay, what remains on the unit? The one that is not cancelled is speed. So after placing all these values here, and after the cancellation, the unit of S will now be in feet. Okay, so we will now take the exact value. 35 times 30 times 5280 over 3600. This is 1. This is 1 times 3600 is 3600. Right? And the unit is now feet. So if we try to get our calculator, the value of S will be 1,450 feet. The distance traveled by the truck after 30 seconds is 1,540 feet. It is this. Okay, I will try to erase this one. And so with this is S. From this point here up to this, that is S. And it's, as per computation, 1,450 feet. Okay, this distance here is 1,450 feet. Right? And the problem is just asking what will be theta. So that's an easy job now because we are given radius and we know the relation of S in terms of theta and r. That's why we study the concepts before solving this problem. So by using the relation S is equal to r theta, angular measurement, right? If we are given a circle like this, right? If this is theta, this is r, and this is s. Okay, we know the relation of s in terms of r and theta. Right? So by using the equation s is equal to r theta. So don't ever try to forget this formula here. That is under the study of trigonometry. Even when you go to higher mathematics, this formula will not change. Okay? So this is a general formula. Solving for theta now, theta will be s over r. Okay? The unit of distance should be feet, and the unit of r should also be feet. So after taking the ratio, the unit will be radians. Okay? It should not be, if this is feet, this is inches, it will not work. Okay? It should be the same unit for the numerator and denominator under this theta here for the unit to be radians. And it's hard to exaggerate a radians, so at least we could exaggerate the degrees. So we will convert this radians to degrees now. So this is times 1 complete revolution, which is 360 degrees. And the equivalent of that in radians is 2 pi radians. Okay? So again, the operation is multiplication. So we are free to cancel this radians here with this. Right? Operation is multiplication. There is no plus sign here or plus sign over here. Because if there is a plus here and a plus here, that's a different story. Right? As long as the operation is multiplication, we could cancel. So this radians here cancel with this. So what remains for the unit of theta, in which we could exaggerate it? The value of theta is 60.85 degrees. Okay? So this angle here is 60.85 degrees. Oh, that's the answer. Okay? It's a simple problem, but we try to solve it, what they call this, the correct way, right? We put the units, then we try to make some calculations. Okay, so we could visualize what we are doing. So actually, we just use two formulas in the computation for the value of theta. That is by using this formula here as an additional under the study of angular measurement. That is linear distance is equal to the constant speed multiplied by time. And the other formula is S equal to r theta. Okay, that's it. This is Professor David J. De Los Reyes. An example problem on angular measurement. Okay, plus our knowledge on linear distance formula. Good morning from Los Angeles. Professor David J. De Los Reyes.